are going to do the inverse method. So 7.3, number 1 is what we are doing today. All right, everybody clear? All right, so let's just pause for a moment, catch our breath. We have substitution, we have elimination, we have Kramer's rule, and now we're learning a 4th method called the inverse method. So, here is what I want you to do. I want you to write down, guys, we don't have much time. I want you to write down 2 matrices. Now, tomorrow, we will be doing, oh, we already did part 2. So, we already did these problems with our calculator. Now we're going to do them by hand. So matrix A is the coefficients. Remember this from last time? Matrix B is the constants. So take a look at number 1A. This is what I've written makes sense to you in light of the problem. Our answer, which is going to be x comma y, just like it is when we do everything else, is going to be the inverse, I'm going to write it in letters, it's going to be the inverse of A times B. Now, we did that exact thing on our calculators last time with a bigger system. Remember typing A inverse times B, and the answer came out. Now we're doing it by hand. So we need to find the inverse of that matrix.
Find the determinant.
Yep, you just did that on your quiz. That should not be a problem for you. A inverse. So to find A inverse, I will find the determinant, and the determinant is -1 minus 6, so -7. Right? Then I will take original A, and I will switch these two. I'm not changing their signs. I am literally moving their position. And then the 3 becomes negative, and the 2 becomes positive. Right? And then to get the inverse, I put them all over -7. -7. So my inverse is actually 1/7, 2/7, 3/7, -1/7. Does that make sense to everyone? That's the inverse. So now I'm going to take that times B, matrix B, which is exactly what your calculator did last time. Now, when I multiply these, notice guys, this is a 2 by 2, and this is a 2 by 1. So it's doable, and I'm going to get a 2 by 1. So 2 rows, 1 column. So I will multiply this by this. Do not let the fraction scare you. There's a common denominator, so you don't even need to worry about it yet. Just do 1 times 8 and 2 times 3. So you get 14 over 7, which is 2, right? So this was 8 and 6. With me? All right, what's this one going to be? 24 minus 3, which is 21 over 7, 3. And there is the answer to the question. So again, for that multiplication, you guys, you're taking 1/7 and 2/7, and you're multiplying by 8 and 3. So that's how we got 14/7, which we reduced to 2. And you'll put down as much work as you need to put. And then we took 3/7 and negative 1, 7 times the 8 and 3. So we got 24 minus 3, 21 over 7. That's how we got the 3. Okay. All right, let's try the next one. We have time for one more. Problem B. So we start by figuring out what is going to be matrix A and what is going to be matrix B. All right, so for problem 1B, matrix A is 4, 3, negative 2, negative 1. Matrix B is 1, 6. Now, don't multiply those two. That's not what we multiply. We multiply A inverse times B. So now we got to find A inverse. All right, so what is the determinant?
Negative 4.
Determinant is negative 4 minus
Negative 6.
negative 6. Did you get 2?
Yeah, it's always A.
So 2, so that would be
And then we make our new matrix, so we take these two. So negative 1 and 4,
negative 1 over 2.
and 2, negative 3. Now, if the fractions bother you, then you can save the 1/2. You're going to multiply all those by 1/2, right? Divided by 2. You can save that and do the multiplication and then take half of those answers. It doesn't matter. So this time I made the fractions and I did the math with the fractions. Here I can do this math. So multiply this times this, and what do I get when I do that? Negative 1, negative 18, negative 19. And then do this times that, and I get 26. Then divide everything by 2. So if you don't want to make the fractions here, it's okay, you don't have to. But you can't forget that. Eventually you have to make the fractions. So what would our final answer be? Negative 19 halves, comma, 13. All right, now I didn't think we'd have time. Let's go to problem 4. We haven't done problem 4 yet. We're going to do Gauss Jordan reduction on our calculators. So get your calculator out. You probably won't get this done, but you can at least get it set up. This problem will be done totally on the calculator. So all you will write down is the matrix that you're going to type into your calculator, and then you're going to do something, or the calculator's going to do something, and a matrix is going to come out, and that matrix is going to give you your answer, X, Y, Z. And it's going to be like this, it's going to be a snap. So what goes in? Well, what goes in is 1, 1, negative 1, 2. So for this method, you make one matrix. You put in your X, Y, Z's and your equals number all in one row. So 1, 1, negative 1, 2. Then 2, negative 1, 3, 14. And then 3, 1, 1, 14. All right, let's put that in our calculator. So we go to second, matrix, edit. What are the dimensions of this one? 3, by 4. 3 rows, 4 columns. All right, so put in your numbers. Get your numbers put in. And tomorrow we will pick up right here. Get the numbers put in.
It would have been 8.
All right.